This is a slide which introduces you about Bluetooth low energy. Before we start, the first requirement is why do you really need Bluetooth low energy? So there's a need to compare with traditional Bluetooth. So traditional Bluetooth is usually connection oriented. In some places they go for sniff mode models to save power. The typical current is 25 milliamps. Though the Bluetooth is claimed to be low energy, it is not that low to cater to energy harvesting applications or consoles. So it created a requirement or a need that you wanted something more which provides you the operation at even more reduced power or reduced energy. So that paved the way for Bluetooth low energy. As I was explaining you in the previous slide, Bluetooth is not able to provide the actual low energy which the applications are expecting. So BLE came as a solution. So this is a new technology which has come up, which uses short range radio, and it operates in two modes. Either you can offer basic rate mode VR or the extended data rate EDR. It operates with ultra low power, and it also enables working with coin cell battery. So and the peak current, if you look at the slide, it's very clear that it is less than 20 milliampere. And the average current is microamp, so it is less than 5 microamp, which makes it very interesting choice for low energy applications. Basic concepts of Bluetooth 4.0 BLE. The first thing is it has low power consumption, which is what the primary point which makes BLE interesting. The other points are it uses short packets in order to reduce the transmit peak current, and it also uses short packets which helps reduce the RX reception time as well. Less RF channels in order to improve discovery and connection time. The next point is it has a very simple state machine, very simple protocol. So these are the points which makes it even more highlighting or interesting about. So this slide gives us the fact sheet about BLE. So the range it can operate is around 150 meters in the open field, which is pretty decent, and then the output power is 10 milliwatts, and we also already saw the maximum current is 15 milliampere. Latency is 3 milliseconds. The usual topology is star. Connections is greater than 2 billion devices, and modulation it uses GFSK. Robustness is achieved through adaptive frequency hopping, and it uses a cyclic redundancy check of 24 bits. And for security purpose, it uses AES, 128-bit AES. And then the modes by which it operates is it operates with broadcasting, connection, event data models, and reads and writes. When it comes to the fact sheet or the performance metrics of Bluetooth low energy, when it comes to data throughput, it is not really meaningful to talk about data throughput because Bluetooth low energy does not support streaming. It is mostly used for sending small chunks of data. So the basic data rate which you can expect is somewhere around 1 megabits per second, and it is not very suitable for file transfers. This slide is actually the extension which justifies the previous slide about the data throughput which we were discussing. I was telling that it is very useful for small chunks of data. So the small chunks of data is what is given in the comment kind of blue boxes which says like now it is 12:23 p.m. or the network is available or not, what operation you wanted to do playing. And then in the airport you can say you have to board at gate number 10 and the temperature now is 23.2 degrees Celsius. This is what is the basic kind of data which BLE can be helpful in communicating to. So it is very good at discrete data transfer, and it is usually triggered by local events. And the given data can be read by multiple clients at the same time, which is a very interesting point. And the basic interface model, it uses GATT, which is in general called as generic attributes model. So as we were seeing the ZigBee stack, this is the stack which explains, or the architecture which explains about Bluetooth low energy. It is divided into three basic broad divisions. The lower part becomes a controller, and the middle is the host, and the on top will be the usual application layer. So always the top layer, considering any model or any technology, the topmost layer is the application. So there's nothing new about it. But when it comes to the controller, it is usually the bottom two layers here, which is basically the physical layer and the link layer. And then there is an interface which talks between the host and the controller, which is given in the dark green color, which is the host controller interface. On top of it, you have this GATT model, which I was saying, the generic attribute model. So you have attribute protocol, and to add security, you have the related protocols coming up. And then you have this access profile, the model which you use to access the channel and things like that, the protocols which defines them, and then your logical link layer and the adaptation protocol. So all this makes your host layer, and on top of it you have a lot of applications which you can deploy, which we already saw in the previous slides, where we had a lot of application modules, like it can be in airports, it could be in temperature measuring of the environment and things like that. This tells about the type of modes available in BLE. So the first one is a dual mode, which supports both BR and the basic rate and the extended data rate, and it is mostly deployed in mobile kind of applications. And in single mode, there is only one model, basic model, which is Bluetooth Low Energy basic model, and it is used in small wearable devices or in remotes. So those are the places where BLE single mode gives an idea about the protocol stacks when considering the dual mode and single mode. So you can have these green boxes which is available in single mode stack. It's been replicated in dual mode stack, which means it's dual mode is something which supports your single mode low energy plus your basic RF model. So those blue boxes are your basic rate RF. Along with that, it supports your basic low energy. So dual mode supports both. And when you look at this BR EDR stack, that is what is your basic RF supporting modules. So that along with your low energy, so together becomes your dual mode. So it is like the green ones are your single mode stack, and the basic rate EDR stacks are the blue ones. So now dual mode is the one which is depicted, which is supporting both. That's why it is given both blue and the green boxes together. And this L2 cap, it's a short form of writing LLCAP, which is logical link control and adaptation layer. So that is nothing new. Instead of double L, it is written L2 cap. This is a assignment slide which I wanted you all to have a look at and then get it practiced. So there's nothing much to explain. It is self-explanatory. You just have to read the question and then the steps are given below. So similarly, any question asked in your exam, you should be able to answer or calculate accordingly. So there are two different questions which the slide helps you to answer. So how do you calculate the energy per transaction? Okay, so that is one calculation which is given here, which is very simple. And how long would a sensor last on a battery? So depending on its usage, how long do you think a sensor will work? So given some attributes, how do you calculate that? So that is the procedure which is given here. You just have to follow it. And the point of difference could be the example battery which is given. The numbers which are given here may be differed, so you should be able to calculate it accordingly. Once the procedure is clear, you shouldn't have any difficulty. This is a slide which tries to explain that every object can become a sensor. So it means to say that you put a sensor into an object and it becomes a sensor, censored object or sensor based object. So now so when you touch your door opener, it can tell you, okay, what is my pulse? So it has a pulse sensor attached to it. And then when you're brushing your teeth, it can say, okay, your blood glucose level is this, because you have a sensor which is put inside, which detects that. And then when you touch your remote, it also has a temperature sensor which can detect your body temperature. So now it all becomes the object in which the sensors are embedded. So the object by themselves, apart from their own job, also gives you some extra details about the person who operates or the environment in which it is put in.